Hello, I'm Dr. David Kordowitz and welcome to Computer Programming. Today we're going to look at putting your first program together and uploading it onto your Arduino Circuit Playground Express. Let's begin. To begin, we're going to open up our Arduino IDE, which we've installed in previous videos. We're going to get a program that initially comes up, which includes two functions, a setup and a loop. The setup function runs at the beginning of the power on to your Arduino. So when you turn power on, it'll run your setup. The loop is run immediately after setup is complete and is run over and over and over again for all time that the Arduino is powered. So for this project, we're going to be using a Circuit Playground Express to create a blinking light. I have a Circuit Playground Express currently connected to my computer, which I am coding on. We'll return to this device once we have uploaded a program to it. The first thing we need to do is go into the Tools menu and make sure that under Board it shows the Adafruit Circuit Playground Express. If it is not showing this, this is located under the Arduino SAMD 32-bit ARM Cortex M0 and about 3/4 of the way down the list. We then also need to make sure that our port is correct. Choose the one that shows the Adafruit Circuit Playground Express or the highest number if you do not see this included. To begin, we need to determine what our setups are. So Arduinos typically have an LED located on board on pin 13. So to configure this, we first must set the pin mode. Of course, an LED is going to be an output because you can't read off an LED. So we're going to say pin mode, and we're going to say that it's pin 13, and we're going to say output. This is telling the Arduino to treat pin 13 as an output. The next thing we need to do is determine whether the light is on or off. We're going to use a Boolean to do this that I'm going to call state. It's going to tell us whether the light is turned on or the light is turned off, and will help us along the way for being able to turn the light on when it is off and off when it is on. We must set this to a default mode, so here after we set our pin mode, we will say state equals 0. As we remember, the Boolean data class only can be 1 or 0, true or false, or high or low. All of these are representations of two states. The Boolean is a single bit. It can have two states. The next thing we're going to do is use a digital write to write the current state to the pin. So digital write is going to take the pin number followed by what we want to write to that pin. So it will be state. This is all of the setup we need for this program. Now, many other programs are going to have much more complicated setups, and you will set those up as you need. This program, though, is simply setting up the port to flash the light and then setting up our state variable. In our loop, which is going to be the meat of our program, the first thing we really want to do is leave the light in the state it's been in for some period of time. We can use the delay command for this. And the delay command takes a number of milliseconds. So let's start with 100. And after 100 milliseconds has elapsed, we want to flip the state. So we're going to say state equals not, which is the exclamation point in C, state. What this is going to do is this is going to take the state and it's going to flip it. So in other words, if the state is 0, it's going to become 1. And if the state is 1, it will become 0. Now we need to go ahead and rewrite this to the port. Again, we're writing the state variable because the state variable has now flipped. Now, once this line completes, it will go back to the top of the loop and it will delay 100 milliseconds. It's then going to go ahead and invert, write, and then delay another 100 milliseconds, invert, write, and it'll keep doing this as long as there's power to your Arduino board. So to write this, we have a few options. At the top, we have verify, we have upload, we have new, open, and save. If you click the verify button, it will compile your code. However, when it compiles this code, it's going to keep it on the computer and not write it to your hardware. The catch is when you hit the upload button to upload it to the hardware, it'll compile it again. So to save time, I would recommend using the upload button as long as you have hardware present. So in other words, if you have your Circuit Playground Express sitting in front of you, go ahead and hit the upload button every time and don't worry about the verify button. The only time I would ever use this is if I don't have an actual Arduino and I'm trying to make sure my code is correct. Then again, if you're in that state, I would recommend using Tinkercad because Tinkercad will give you an option to simulate the actual Arduino operations. So let's go ahead and upload this code to the board. The first thing it's going to do is ask us to save our code. These are what we call sketches. Arduino uses the term sketches instead of programs. But we have a sketch and it's going to by default give it today's date as the file name. Now it's going to start with the letter A and it's going to increment B, C, D, E, F through the alphabet. This incrementing will happen with every new sketch you create on that same day. Now it's important to note that say a year goes by, you're going to end up on the same day. Therefore, it will just continue in the C, D, E, F progression as you would expect. So for today, I have it set to August 17th, C. So let's go ahead and save that. And now it's going to begin to compile. It'll say compiling sketch down here on the green bar, and you're going to see the outputs down here on the bottom bar. So now our Arduino has had the code uploaded to it. It says done uploading, which tells us that that's correct. You saw that error message flash really quickly. What that's for is the Arduino Adafruit Circuit Playground Express supports more than just Arduino languages. And so it's going to try to put it as a drive on your computer for using Python. Since you're not using Python, you'll hear it add that drive and then it'll immediately remove it. And sometimes you'll get just a small error about that and just click OK. But our code is now uploaded to our board. So let's flash over to our board. If you notice over here, we have an LED D13. That LED is flashing now. It should be on for 100 milliseconds and off for an additional 100 milliseconds, meaning the cycle is about 200 milliseconds or 0.2 of a second. So let's go ahead and extend this. Instead of 100, I'm simply going to change in my code to 500 and upload this to the board again. This will take just a minute. Now if you notice, the speed of the flashing has slowed down. The whole cycle of the light being on and the light being off should now be 1 second because it is 500 milliseconds on and 500 milliseconds off. I'd like to thank you for your time today and see you next time.